Ruben left early. All right, we are talking about lesson 7.5. This is our second day, linear inequalities, part 2. Okay, many situations are modeled by inequalities that have a boundary line of the form ax plus by equals c. That is standard form. You can use your intercepts, your x and your y intercept to graph that boundary line, and then choose a test point not on the boundary line to determine whether the solutions are above or below. It's really the same exact thing that we did on Friday, okay? But it is in standard form. So, suppose your budget allows you to spend no more than $24 for decorations for a party. Streamers cost $2 a roll and tablecloths cost $6 each. Use intercepts to graph the inequality that represents the situation. And then find 3 possible combinations of streamers and tablecloths that you can buy. So, we're going to let x equal the number of streamers and y equal the number of tablecloths. Who can give me the inequality that would represent this situation? Tyson. Is Tyson right? Yes, it says no more than 24. So could I spend 24? Yes. I could spend 24 or less. So, if I want to graph that using my x-intercepts, I would put, I'm going to call this x and y. I think it just makes more sense. Whatever. If I put 0 in for y, x will be 12. And if I put 0 in for x, y will be 4. So, I'm going to graph this. Streamers are the x and tablecloths are on the y. Now, I have something very important to point out. I'm going to plot those 2 points. And I'm going to draw a solid line. Why is it solid? Because it has equal to. Why does it not have arrows? This line. You can't have negative streamers or tablecloths. Either one. So this is a first quadrant only graph. And if I ask you to graph something like this, I would expect to see those endpoints and no arrows. Because it's not a realistic situation to be up here, which would be negative streamers, or down here, which would be negative tablecloths. Now, where would we shade? Well, let's try 0, 0. Let's just make sure, right? If I put 0, 0 in, is 0 less than 24? Yes. So our shading is right in that triangle. And notice, my shading isn't going all over the place either, because it is a first quadrant only graph. Now, they told us they want 3 possible combinations. So, I could find any combination that is in this shaded area. I'm going to start with 1 streamer and 1 tablecloth. So 1 streamer, 1 tablecloth. Could I do 2 streamers and 2 tablecloths? Could I do 3 and 3? Let's see. 3 and 3. It looks like it might. Well, how would I check? How can I find out? Let's do 3 and 3. If I did 2 times 3 plus 6 times 3, that's 18 plus 6, it is 24. So I could do 1 and 1, 2 and 2, 3 and 3. Or you could be more interested in 2 and 2 kind Yeah, you could do 0 and 0. All right. Let me